This is the screencast for example 6, identifying a piecewise function. A piecewise function has pieces of several functions put into it to make one function. In the piecewise function in example 6, the two pieces being used are y equals x and y equals negative x. So the line y equals x has a positive slope of 1, y-intercept 0, and the line y equals negative x has a a slope of negative 1, also y-intercept of 0. The example asks me to find which of the 12 piecewise functions which of the 12 basic functions has the following piecewise function definition over separate intervals of its domain. So I need to sketch this first to see what it looks like before I can identify which basic function it looks like. Let's see, so one piece starts at x equals 0, and that's where the other one leaves off. The boundary is between the y-axis, basically. For the values, the x values greater than or equal to 0, the piece looks like y equals x. So that is the line of slope positive 1 with y-intercept also positive, or y-intercept 0. The piece for x values less than 0, so to the left of the y-axis, looks like a line whose slope is negative 1, also y-intercept 0. Now to me that looks like the absolute value of x function. So the basic function, whose piecewise function is defined like this, is y equals absolute value of x. The now try problem is example 45. It says sketch the graph of the piecewise defined function, and try it without a calculator. Well, I haven't shown you how to do it with a calculator yet, so at the end of this construction of the piecewise function, I will show you how to do this in your calculator. Very much like example 6, one piece starts at x equals 0 and the other one leaves off at x equals 0. In other words, the y-axis is the boundary between these two pieces. This first piece, y equals x, is defined where x is less than or equal to 0, so to the left of the y-axis. The line y equals x has a positive slope of 1, and that means we're going to end it right at the y-axis. The second piece of this function is the function y equals x squared, which is defined after the y-axis, where the x values are bigger than 0. That's your basic parabola that goes through the origin. So this is a sketch of the piecewise function defined in number 45. To see that on my calculator, I have to put each piece separately into my calculator. So I'm going to put in y1, and I am going to put it in parentheses just for practice purposes. I'll show you why in a second. The function y equals x needs to get multiplied by some parameters so that it only occurs where x is less than or equal to 0. So I am going to open up a set of parentheses to multiply the function by these parameters, and I'm going to say that x has to be, hit your second key, and then above the math button, 2 buttons down, is the word test, so second test, and then you see less than or equal to, so that's number 6, 0. So now you have just told y1 to graph the value x, or graph the function x, only for values less than or equal to 0. In y2 then, we're going to put x squared in parentheses, the other basic function we want a piece represented of, and I'm going to multiply by the parameters x, second test, is just greater than, so 3, 0. And I'm going to hit zoom 6. And I did graph that function in my sketch almost as well as the calculator did.